Welcome back to my channel. Okay, in this video, I'm going to discuss about finding the sum of the terms of a given arithmetic sequence.
When I wake up, I feel cozy, yeah. Can you hold up? Don't need no coffee yet. Got no makeup.
There are two formulas that we are going to use. S sub n stands for the sum of n terms equals n over 2 times the quantity a sub 1 plus a sub n, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. This formula is only used if the given is the first term and the last term. The other one, if the last term is not given. So S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times t. So this formula is used if the last term is not given. For example, number 1, find the sum of the first 20 natural numbers. So start with 1, 2, 3, 4, 5, up to 20. Okay, solution. Our first term is equal to 1. Because starting 1, 2, 3, 4, first 20 natural numbers. And our last term is equal to 20. How many terms? There are 20 terms. Okay? So we can use the first formula. S sub n equals n over 2 times a sub 1 plus a sub n. Okay. Then substitute. S sub 20, when to say sum of the 20 terms, first 20 terms. So 20 over 2, then the first term is 1, plus the last term is 20. Okay, this will be 20 divided 2, that's 10. 1 plus 20 is 21. Multiply these two numbers here, the result is 210. Therefore, the first 20 natural numbers, the sum of the first 20 natural numbers is 210. Okay, example number 2, find the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, 20, and so on. Okay, solution. Let us identify the first term. What is our first term? The first term is 8. Do we have last term? No. We have no last term because this sequence is continuous. No. Now, what is our common difference? The common difference is 3. Yes. What is our term, number of terms? So we are asked to find the first 16 terms. So our n is 16. Okay? Now, since we don't have the last term, we use the second formula. Okay? S sub n equals n over 2 times 2 a sub 1 plus the quantity n minus 1 times d. Okay, by substitution, S sub 16, because we want to find the sum of the first 16 terms. 16 over 2, 2 times the value of a sub 1 is 8, plus n is 16, minus 1, then the common difference is 3. Okay? 16 divided 2, that's 8. 2 times 8, that is 16. Plus 16 minus 1, that is 15. Times 3. Okay. S sub 16 equals 8. 16 plus multiply first 15 and 3, that is 45. Okay. S sub 16 equals 8 Then get the sum of 16 and 45. That is 61. Then multiply 61 and 8. So S sub 16 is equal to 488. So this is the sum of the first 16 terms of the arithmetic sequence 8, 11, 14, 17, 20, and so on. Okay, let us solve for example number 3. If the first n terms of the sequence 9, 12, 15, 18 are added, how many terms give a sum of 126? So let us have a solution here. Let us identify the given. We have the first term as 9, and the common difference is equal to 3. Okay? The problem asks how many terms. So, and is we do not know. And for the sum of these n terms, is 126. Okay? So let us use the second formula because we don't have the last term. So we have S sub n equals n over 2 times 2a sub 1 plus n minus 1 times d. Then by substitution, we have S sub n, S sub n is 126. So this will become 126 equals n over 2 times 2 times the first term 9 plus n minus 1 times the common difference 3. Okay? Copy 126 equals n over 2. Multiply these two numbers here, that's 18, plus distribute 3 to n minus 1. 3 times n, that's 3n. 3 times negative 1, that's negative 3. Okay? Copy 126 equals n over 2. We can combine 18 and negative 3, that is 15. So 15 plus 3n. Okay? Then, we can cross multiply 2 to 126. So 2 times 126, that is 252. Cross multiply. So you become n times 15 plus 3n. Okay? Then 252 equals, distribute n, that is equal to 15n plus 3n squared. This is a quadratic equation. Transpose 252 to the right side, this will become 0 equals 3n squared plus 15n minus 252. And this quadratic equation can be simplified into lowest term, or can be lowest term, or the common factor is 3. So 0 equals n squared plus 5n minus 84. Okay? The common is 3. So 3 divided 3, that's 1. 15 divided 3, that's 5. Negative 2, 5 to divide 3, is negative 84. Then we are going to factor out this quadratic equation here. Factor of n squared is n times n. Factors of negative 84, that the sum is 5. So that is plus 12 and minus 7. So if you multiply 12 times negative 7, the result is negative 84. If we add 12 plus negative 7, the result is 5. So that is how we factored out. Okay, so then let us equate the two factors to 0. So n plus 12 equals 0 and n minus 7 equals 0. Solve for n equals negative 12 and n equals 7. So we have two numbers of n here, but we are going to select the positive one because there is no negative number of n. So therefore, n is equal to 7. So there are 7 terms. Kung imong i-add ang 7 terms from 9 until 7 nga terms, the result is 126. So therefore, the value of n, or how many terms? So there are 7 terms that we are going to add that the sum is 126. Example number 4, find the sum of the integers between 1 and 70 and are divisible by 3. Okay, so from 1 to 70, numbers that divisible by 3 started with 3. Next is 6. Next is 9. Next is 12. And the last term from 1 to 70 that is divisible by 3 is 69. So here, we can observe that the first term is 3. The common difference is also 3. And the last term is equal to 69. Okay, from 3 to 69, wala ta kay ba pila ka book number of terms. So first, we are going to find the number of terms because we cannot solve this problem without the number of terms. So by using the n term of the arithmetic sequence in solving for the number of terms, n. So the n term is a sub n equals a sub 1 plus n minus 1 times d. Again, we cannot solve the problem without the number of terms. So we are going to find first the number of terms by using the n term of arithmetic sequence. So let us substitute that 69 equals the first term is 3 plus n minus 1 times the common difference is 3. So we have 69 equals 3. Distribute, that's 3n minus 3. 3 minus 3, that's 0. So this will become 69 equals 3n. Then let us divide both sides by 3 to solve for n. Divide both sides by 3. Therefore, n equals 23. So there are 23 terms from 3 to 69. So we can now get the sum. It's either of the two formulas that we are going to use because we have the last term, we have the number of terms, and we have the first term. So let us use the first formula. S sub n equals n over 2 times a sub 1 plus a sub n. Okay, then substitute. We have s sub 23 equals 23 over 2 times the first term 3 plus the last term 69. Then s sub 23 equals 23 is not divisible by 2, so let us leave this one as a fraction. Then add 3 plus 69, that's 72. Okay, in this case 72 is divisible by 2, so we can divide 72 by 2. That is 23. 72 divided to this 36. So get the sum of 23 times 36. The result is 828. Therefore, the sum of integers between 170 that are divisible by 3 is 828. Okay, let us have an example number 5. The sum of the first 15 terms of an arithmetic sequence is 765. If the first term is 23, what is the common difference? So let us solve the sum of the first 15 terms. Sum of the first 15 terms, that is S sub 15, is 765. And the first term is equal to 23. So n is equal to 15 because there are sum of the first 15 terms. That's n equals 15. So what is asked in the problem is the common difference. So we are going to use the second formula of the sum of the arithmetic sequence. So S sub n equals n over 2 times 2 times a sub 1 plus n minus 1 times d. Okay. Substitute S sub 15 is equal to 15 over 2 times 2 times 23 plus 15 minus 1 times d. Okay? So, S sub 15 equals 15 over 2 multiply 2 times 23, that is 46, plus subtract 15 and 1, that is 14. This will become 14D. Okay. And what is S sub 15? S sub 15 is 765 equals 15 over 2 times 46 plus 14D. Di man ma-divide si 15 ni 2, so we are going to cross multiply 2 to 765. So, yato ni siya i-multiply. 765 times 2. 0, 1, 3, 1. That's 1,530. So, 1,530 equals 15 times 46 plus 14D. Okay, copy 1,530. Distribute 15 times 46. So, 46 times 15, 30. That's 23. 6. That's 4. 0, 9, 6. That is 690. Plus, multiply 15 and 14. 20. 6, 5, 1, 0, 1. 210. That's 210. That's 210D. Then, transpose 690. So, mayroon siyang 1,530 minus 690 equals 210D. Subtract these two numbers. Okay. That the result is equals 210. Divide both sides by 210 to solve for D. Cancel. Therefore, the common difference is, that is 4. So, 840 divided 210, the answer is 4. So, therefore, the common difference of this problem is 4. That is how we are going to find the sum of the terms in arithmetic sequence. So there are two formulas that we are going to use. It's either of the two. So we can use the first one if the first and the last term are given. And we can use the second formula if the last term is not given. Okay, thanks for watching, and I hope you learned something in my discussion today. And if you are new in my channel, do not forget to subscribe and click the notification bell so that you will be updated for more videos that I'm going to upload in my channel. Thanks for watching and good day.
Don't need no coffee yet.